Introduction to Stream API in Java. Introduction to Stream API. Hello, everyone. We're going to look into one of Java 8's powerful addition, which is the Stream API. This feature has changed how we handle collections and data in Java, emphasizing a functional programming approach. What is the Stream API? So the Stream API is a modern feature that allows us to handle sequences of data in a declarative way. So you can picture like a stream as a conveyor belt of data elements where you can perform operations like filtering, sorting, and transforming. Importantly, these elements are processed on demand, and this makes streams incredibly efficient. Streams are particularly great because they can be processed and parallel easily, optimizing performance without complex code. Stream operations overview. So when you're working with streams, you need to distinguish between two main types of operations: intermediate and terminal. So intermediate operations, such as map and filter, transform the stream into another stream and are lazy. What we mean by lazy in this context is that they don't perform any processing until a terminal operation is invoked. Terminal operations like for each and collect produce a final result, or you can call it side effect, and close this stream. So it's important to understand this distinction, which is crucial for efficient stream operations. Intermediate operations. So we talked about intermediate terminal operations. Let's look into intermediate operations. Operations like map apply a function to each element. So we're transforming them one by one. And filter lets us exclude elements based on a condition. And limit is useful if you want to truncate the stream to a specified number of elements. And these operations are powerful for manipulating data without altering the original source. So if we look at this example, we are creating a list of names, and then we want to use Stream API to create short names. So we'll call stream and then filter any names that has a length greater than 4. And then we would transform these names into uppercase, and we would truncate the output to specify elements, and then we'll need to call collect, which is a terminal operation we'll learn, and this will create short names that has output of Bob and Dave, and we haven't modified the original names. Terminal operations. So now we looked at intermediate operations. Let's move on to terminal operations. These are where the action happens. For each reduce and collect are 3 operations, and for each applies a function to each element, typically performing side effects. And reduce is a powerful operation for combining all elements in the stream into a single summary result. And lastly, collect, we've seen collect. Collect gathers elements into a collection like a list of or a map, which is useful for accumulating results. So let's take a look at this. We have a list of numbers, and we're calling for each, and this prints out each number. And what happens, reduce, this prints out sum of all numbers, and we have collect here. Collect basically just accumulate results. Creating streams. So how can we create streams? We've seen a couple examples. There are several ways. As you've seen, you can create a stream from any collection using that stream. For arrays, arrays.stream is your go-to. And for infinite streams, what we mean by infinite stream is that streams are not bounded by a finite size. You can use stream.iterate and stream.generate. So these creators are foundational for working with streams effectively. And we've seen regular stream as shown in the example. Here we can see the infinite stream. Here we have no bounds, so we're calling iterate. So we've seen a lot of examples, but let's kind of re-look at this example for filtering and counting. Say we are given a task to count how many names in a list have more than 5 characters. Then we can use the stream API. So we will call stream method on the list and then apply filter with a lambda expression to check the length. And if the length is longer than 5, it will return true. Then finally call count to count the result. Then this will return 3. So you can see that this code using stream API and lambda expression is not only concise, but also very readable. Example 2 is using mapping and collecting. Say you're given a task to convert all names in a list to uppercase and collect them into a new list. This is something we've seen in previous slides, very similar. And we can do this by streaming the list, by calling stream method, and apply map operation with string to uppercase, then collect the results with collectors to that to list. This demonstrates the stream API's capability to transform data efficiently. Benefits of using stream API. You might be wondering why we need to use stream API. first reason is Stream API simplifies parallel operations. So you can convert a sequential stream to a parallel one simply by changing stream method to parallel stream. When you change from stream to parallel stream, what happens is this leverages multi-core processors effectively. Additionally, streams lead to more readable and maintainable code, and they also potentially optimize performance, especially when dealing with large data sets. Conclusion, to conclude, the Stream API is, I would say, one big shift in Java programming, encourages more functional style of coding. So I definitely encourage you to use Stream API when you're working on Java project and explore its various methods. It might not look intuitive right now if you're not familiar with functional way of programming, but the more you use it, the more intuitive it will become. Thank you for listening.